Cool. How can we define this system explicitly? Colloids को, I mean, obviously we are studying surface chemistry and here we are majorly looking at phenomena happening at surfaces, because of which we are looking at most of the things in terms of mixtures. पहला लिया हमने catalysis, uh, then colloids. Solutions हम लोग पढ़ चुके हैं ऑलरेडी. So इंटरैक्टिव फिनोमेना किस किस तरह के होते हैं, उससे क्या क्या सिस्टम जनरेट होते हैं, दैट इज व्हाट वी आर लुकिंग एट. Colloids is actually a mixture, I mean, a heterogeneous mixture uh, in which the particle size of solute or the minor component ranges between 1 nanometer to 1000 nanometer. ठीक है, such that it must not become true solution where it get dissolved completely into the solution solvent, nor does the solute particles be big enough to not get completely dissolved, to not get dissolved at all and remain visible. ठीक है, either by naked eye or by simple lenses. सो एक एंड पर ट्रू सॉल्यूशंस और दूसरे एंड पर जब विजिबिलिटी होने लगती है पार्टिकल्स की तो इट बिकम्स सस्पेंशंस. So colloidal is a phase in between these two extremes, true solutions and suspensions. True solutions is at one end and suspension is on other end. So colloidal is a phase which is in between true solution and suspension. So to begin with, colloids are homogeneous mixture Uh, so colloids are heterogeneous mixture where their properties are going to be in between true solutions. The physical properties are going to be in between true solutions and suspensions. ट्रू सॉल्यूशंस में कुछ भी नहीं दिखता है, पार्टिकल्स सॉल्यूट पार्टिकल्स बिल्कुल ही नहीं दिखते हैं इवन अंडर स्ट्रॉन्ग माइक्रोस्कोप। और सस्पेंशंस के अंदर में दे आर ऑलमोस्ट विजिबल बाय नेकेड आई, इफ नॉट बाय नेकेड आई, और स्मॉल पीस ऑफ लेंसेज कैन मेक देम विजिबल डेफिनेटली। ठीक है, सो दिस particle size difference of solute is going to impart some definitive character to the colloids, ठीक है, which we are like कुछ optical properties इनकी enhance करता है, and certain other things like particle size छोटा होने, मतलब true solutions जितना completely disperse नहीं होता है ना, इसलिए अपने फेज को मेंटेन रखता है colloid, ठीक है। येट पार्टिकल साइज छोटा होने के वजह से द एक्सपोज्ड सरफेस एरिया becomes too large, ठीक है, and large surface areas are always good for better and faster reactions. More the exposed surface area will be, faster will be your reaction because of chances of direct interaction between the two sets of reactant which are trying to react, ठीक है। So these are subtle benefits which we are going to get from colloidal phase. We are going to look at them one by one. uh, The major phase of colloid is known as dispersal medium. The minor phase of the colloid is known as dispersed phase. The size of this, the particle size of dispersed phase uh, is such that it's like mm, it's not visible by naked eyes, uh, nor it is completely gone away. Like uh, it's between the two. The unique range of particle size of dispersed phase imparts see, colloids can be classified on various categorizing parameters such as physical state of dispersed phase and dispersal medium, interaction between dispersed phase and dispersal medium, and types of particle of dispersed phase. So we are going to look at them one by one. Uh, See, इस categorization method इस broader category के अंदर we have in total 9 system, sorry, 8 systems. Uh, solid in solid, solid in liquid, solid in gas, liquid in liquid, liquid in solid, liquid in gas, and then gas in solid and gas in liquid. Gas in gas can never be colloidal. They are always true solutions or homogeneous mixture. They can never be colloidal. Heterogeneous नहीं हो सकते हैं. ठीक है. So total 8 categories. 1, 2, 3, 4, 5, 6, 7, 8. ठीक है. और solid in solid is called solid sol. Solid in liquid is called sol. Solid in gas is called aerosol. Liquid in solid is called gel. Liquid in solid is called gel. जितने भी जेल आप लगाते हो they are mostly gels. I mean those gels are basically a heterogeneous mixture of liquid and solids. In general, they can be homogeneous also, but जनरल लिंग्विस्टिक्स में हम उनको डिस्टिंग्विश करते हैं. एक को सॉल्यूशन जब होता है वी कॉल देम पेस्ट एंड इनको जेल्स बोलते हैं. बट that's not something which you can relate based on the name or categorization which has been done based on marketing. ठीक है. However, the literal meaning of gel and pastes are like this only. They are true solutions and gels are colloidals. Liquid in liquid, colloidal is known as emulsion. Liquid in gas is known as aerosol. Solid in gas is also known as aerosol. Liquid in gas is also known as aerosol. Gas in solid, solid sol, solid in solid, or gas in solid. It's solid sol. Gas in liquid, it's known as foam. Gas in liquid, it's known as foam. ठीक है. So these are eight categories of colloids based on physical state of dispersed phase and dispersive medium. ठीक है. बेसिकली ये नेम्स जो हैं ये आप लोगों को थोड़े से ध्यान रहने चाहिए. डायरेक्ट क्वेश्चंस आने के चांसेस नहीं होते हैं, बट दे कैन बी पार्ट ऑफ अ स्टेटमेंट. ठीक है. सो दिस इज समथिंग जो आपको थोड़ा सा कनेक्ट रहना चाहिए. एग्जाम्पल्स, कैटेगरी वाइज जो एग्जाम्पल्स हैं ये ध्यान में रहने चाहिए. These can again be part of statements. This is this type of colloidal, and it's not very difficult to like I'll not say memorize, rather to understand. Some colored glasses and gemstones. And then gemstones are always solid sols. Generally alumina and silica का crystal होता है Al2O3 and SiO2. और उसमें कभी फेरस जाता है, कभी क्यूप्रस जाता है, और जिंक जाता है, बाकी सारे जाते हैं. उसके बेसिस पर ये कलर इम्पार्ट करते हैं जेमस्टोन्स को. isn't it? Right?
Okay.
ठीक है,
Yes, sir.
दैनेश, पढ़ा है ये चीज आपने?
No, sir.
इफ नॉट, और एनसीईआरटी पी ब्लॉक वाला जो है सिलिकॉन चैप्टर 14 ग्रुप, वो एक बार पढ़ लीजिए आप, और दैट विल गिव यू सम आइडिया. अदरवाइज I'll send a few texts, एक दो pages that you can go through. Gemstones are primarily, all the gemstones are alumina and silica, mix of alumina and silica. ठीक है, और उसमें अलग अलग कलरिंग एजेंट्स इंट्रैप हो जाते हैं. कलरिंग एजेंट्स मतलब अलग अलग आयंस इंट्रैप हो जाते हैं, मेटल आयन, डी ब्लॉक मेटल आयन, which imparts color to those gemstones. ठीक है, तो वो जो इंट्रैप्ड आयंस होते हैं, एटम्स होते हैं इन दिस एल्यूमिनियम सिलिकेट क्रिस्टल, तो they form kind of solid into solid. Then you have solid and liquid pent cell fluids. All our pents, पेंट्स एज इन जितने भी ऑर्गेनिक पेंट्स, ऑर्गेनिक मतलब जितने भी पेंट्स, पॉलीमर पेंट्स हम लोग देख रहे हैं आजकल, मे इट भी जो वाटर के साथ अप्लाई नहीं होते या वाटर कम पोर्शन में यूज होता है उनमें, इंक्लूडिंग हमारा ये ग्रिल वगैरह पेंट करने के लिए जो ले करके हम लोग आते हैं लोहे को पेंट करने के लिए या दीवार को पेंट करने के लिए, बोथ ऑफ देम आर काइंड ऑफ सॉल्ट्स ओनली, सॉलिड इन लिक्विड, dispersed solids dispersed in liquids, solid in gas, aerosols, smoke, dust, liquid in solid, cheese, butter, zellage. Liquid in liquid, emulsion, milk, hair cream. Milk is the best example of emulsions. So, milk and hair cream, they are types of this emulsion. Then, liquid in gas, that's again aerosol, fog, mist, cloud, insecticides, sprays. Gas in solid, that's solid sol, pumice stone, foam rubber. Then gas in liquid, foam, froth, whipped cream, soap, leather. They all are gas in liquid colloids, termed as foams. ठीक है, सो इंफॉर्मेशन यहाँ पर जो कैप्चर करनी है आपको प्राइमरली, वो है नाम ऑफ टाइप्स. सो ये आपको ध्यान रहना चाहिए, या ये आपको ऐसे बोलो याद रखना पड़ेगा. You have to do it. You don't have an option. ठीक है, तो अब इसको छोड़ के चार बचे. ये चार है जो कि पेयर्स में है, एंड बाकी चार अलग नेम्स हैं, वो याद रखेंगे आप लोग, वो याद ही रखना पड़ेगा. The second categorization is based on nature of interaction between dispersed phase and dispersion media. Nature of interaction between dispersed phase and dispersion. There are two types: lyophilic, philic, and lyophobic. Lyophilic means solvent loving solute. Solute. एंड दूसरा होता है लायोफिलिक सॉल्वेंट लविंग सॉल्यूट एंड दूसरा होता है लायोफेबिक फोबिक सॉल्वेंट हीटिंग सॉल्यूट. So it's not actually hating, it's actually not loving. ठीक है. So basically होता है लायोफिलिक में ये होता है कि the extent of interaction between dispersed phase and dispersed medium is greater, whereas lyophobic में it's very less and it is primarily यहाँ पर जो होता है interactive nature that is only because of inertia. ठीक है, मास की वजह से जो इंटरेक्शन हो सकता है बस वही रहता है, उससे ज्यादा कुछ नहीं रहता है. यहाँ पे दो तरह के इंटरेक्शंस रहते हैं. पहला चार्ज इंटरेक्शन और डाइपोल इंटरेक्शंस और दूसरा obviously inertia interactions. Is that okay? Inertia interactions are quite low, they are always going to be very low. Compared to dipole interactions that give them name lyophilic and lyophobic. Lyophobic, it's again not, again I'm saying it's not a repulsion, rather it's not uh, non-attraction. ठीक है, not loving or non-attractive versus attractive. Lyophilic means attractive nature, whereas lyophobic means non-attractive nature that is not going to respond positively to its environment. जैसे oil put in water. That's a kind of Liophobia colloid, right? Water in oil or oil in water. So that is something they over there. Okay. Uh, Second thing about them is they are reversible in nature. A reversible uh, colloids. Uh, these are irreversible. Reversible in the sense that if we tend to separate the dispersed phase and dispersal medium of lyophilic uh, solute, or somehow due to external force or external practices, if we are able to separate the dispersed phase and dispersal medium uh, from each other, and then we try to bring them back, the lyophilic solutions are going to or lyophilic colloids are going to form on their own. मतलब डिस्पर्स फेज डिस्पर्सन फेज मीडियम को हमने मिक्स किया, कोलॉइड बना, कोलॉइड को सेपरेट किया, डिस्पर्स फेज डिस्पर्सन मीडियम बन गया, वापस से उनको मिक्स करेंगे, दे विल इमीडिएटली फॉर्म द कोलॉइडल सॉल्यूशन. दैट मींस दे आर रिवर्सिबल. We can separate them using some external means. Whenever we want to recombine them, we can just mix them and they will form the collider. ठीक है? The colloid which disperse phase generally liquid. The colloids in which disperse phase generally liquid. Correct. In it's not dispersed phase which is liquid, it is dispersed medium which is liquid, in which dispersed phase and dispersed medium. Dispersed medium is generally liquid. has attractive attraction. Generally, generally क्या always dipole dipole से ज़्यादा stronger interactions नहीं हो सकता has attractive interaction in form of dipole dipole or of dipole interaction. It's not actually only dipole and inverse dipole. It is dipole interaction. You can say. Dipole has attractive interaction in form of dipole interactions. Because of this attractive interaction between dispersed phase and dispersal medium they can easily combine to form colloids even if they are separated. separated. Separated and then allowed to this may lyophilic colloids, lyophilic colloids reversible in nature and hence they are referred as reversible colloids. Examples of lyophilic colloids are uh, gum mixed with water. ठीक है, और gelatin or even starch, they also mixed with water. ये वाटर के साथ भी और इनफैक्ट अल्कोहल वगैरह में भी अगर हम इनको डालते हैं, they are going to form that colloids. So this can be water, alcohol, uh, फिर aldehyde ketones. So basically मैं कर क्या रहा हूँ हर बार, what I'm trying to look at is polarity. ठीक है ना, बात समझ में आ रही है? मॉलिक्यूल में, सॉल्वेंट मॉलिक्यूल में पोलैरिटी होनी चाहिए, तभी तो अट्रैक्टिव इंटरेक्शन दे पाएगा ना, और तभी हमारा ये कोलॉइड फॉर्म कर पाएगा. ठीक है, सो एंड देन वी हैव रबर आल्सो. रबर, in fact natural rubber is a colloid only, mixed with obviously water में mixed रहता है, वाटर को सेपरेट करते हैं और फिर कंडेंस्ड मटेरियल जो होता है उसको निकालते हैं.
आइसोप्रीन होता है ना.
हाँ, आइसोप्रीन इन वाटर.
एंड वाटर.
और ठीक है, और भी है, मतलब ये इट इज नॉट लिमिटेड टू दिस ओनली. हमारा जो भी डेयरी प्रोडक्ट्स होता है ना, जैसे दूध फट जाता है एंड वी टेक आउट दैट, क्या बोलते हैं, पनीर आउट ऑफ इट. ठीक है, तो वो जो फटना प्रोसेस है, व्हाट इज दैट? वो एक्चुअली हमारा रिवर्सिबल कोलॉइड जो है, वो मिल्क इज अ इमल्सन, इमल्सन इज अ कोलॉइड. ठीक है, तो हमारा मिल्क जो है, वो अब मिल्क जो है दैट इज अ कोलॉइड, जिसमें dispersion phase and dispersion sorry dispersed phase and dispersion medium. Medium is water, dispersed phase is the actual proteinous content, protein, yeah, my days, lactic acid and protein, जो मिल्क प्रोटीन होता है वो, that is dispersed in that liquid water. अब जब वो, देयर इज अ प्रोसेस कॉल्ड कोएगुलेशन, थोड़ी देर में पढ़ने वाले हैं, दैट इज फॉर्मेशन ऑफ एग्लोमरेशन ऑफ डिस्पर्स्ड पार्टिकल, जो है स्प्रेड आउट पार्टिकल्स जो है उनका एक साथ आके कंबाइन करना इज कॉल्ड कोएगुलेशन. ठीक है, तो कोएगुलेशन हो करके वो कंबाइन करके फिर बाहर निकल जाते हैं and it breaks. However, ठीक है, that would be an example of reversible colloid. वो पनीर वगैरह का separation है, that would be a reversible colloid. That's an irreversible process. Once done, it cannot re-enter into original phase. So well, that cannot be an example of this, but obviously these are definitive examples of that. Uh, The second type is, the first type was this lyophilic, and the second type is lyophobic. Lyophobic colloids, and there is no interaction or very weak interaction between dispersed phase there is no interaction or very weak interaction between dispersed phase and dispersion medium. Due to this, if the dispersed phase separated from dispersion medium, then they cannot combine. If the dispersed phase is separated from dispersal medium, then they cannot combine to form colloids on their own. Thus, it is, or this is thus, it is the irreversible colloid. Irreversible colloid. इनको हमेशा लायोफिलिक कोलॉइड्स को फॉर्म करने के लिए हमेशा we require external interactions काफी weak है, so we always require external agents or external help in order to form these colloids. Yeah. In the formation these colloids always requires external as in form of external agents, external or external agents. एक छोटी सी चीज और इस वाले केस में not only does that their formation at time of formation they require external help or external agents, rather even once they are formed, in order to keep that colloid phase, uh, they require an external support. That external support is termed as stabilizing agents. Okay? That means in order to continue the lyophobic colloidal phases, we require some stabilizing agents. If we don't provide those stabilizing agents, the interaction between the dispersed phase and dispersion medium won't be live uh, or won't be carried on its own, and therefore the dispersed phase will become separated or will uh, ultimately get separated from dispersion medium. See, मतलब ये है इनके बीच में डिस्पर्सन फेज जो है और डिस्पर्सन मीडियम जो है, डिस्पर्स्ड फेज और डिस्पर्सन मीडियम के बीच में देयर इज नो strong interaction. ठीक है, या there is hardly any interaction. So you require something externally or something to be put externally which can hold the dispersed phase in dispersion medium. Otherwise dispersed phase क्या होगा, that will eventually settle down as a suspension. ठीक है, that will settle down as a suspension if they are not pulled back with the dispersion medium. Now the point is this external agent, yeah, external factor which is applied in the uh, Liophobia colloids to make them stable is are known as stabilizing agents. Stabilizing agents. Okay. So Liophobia colloids always require stabilizing agents. In case of lyophilic, we do not require any external stabilizers. Okay. For the reason they can recombine or there is a permanent interaction happening between attractive interaction of obviously smaller level happening between dispersed phase and dispersion medium. Okay, dispersed phase and dispersion medium. Therefore, they are not going to require any stabilizing agents, whereas lyophobic colloids they always require a stabilizing agent. तो यहाँ पर एक आखिरी point वो not require stabilizing agent. whereas uh, Liophobia Colloids are colloids. Liophobia colloids require a stabilizing agent in order to order maintain colloidal phase. Otherwise, otherwise, as for interaction between the phase, dispersion dispersed phase in dispersion reactions. Interaction between dispersed phase and dispersion very low. They easily separate. They easily separate. Okay. Examples of lyophobic colloids are especially D block elements, ठीक है, D block metals, obviously fine particles put into water with water, and you have a lyophobic colloid. Similarly, almost all metal sulfides put into water or even alcohol, water or alcohol. ठीक है? They are these colloids, phobic colloids. ठीक है? Uh, the third categorization is based on types of particle, types of particle of dispersed phase. Over here we have three categories: multimolecular colloid, macromolecular colloid, and associated colloid. Multimolecular colloid. और मल्टीमॉलिक्यूलर कोलॉइड का मतलब होता है a single colloid particle, a single particle of dispersed phase is not that big enough to suffice the need of 1 nm to 1000 nm this thing, particle size configuration. ठीक है? So what these molecules do is they uh, combine in certain numbers, 50, 100, 200, 500 एक साथ आ जाते हैं, and that's how this colloidal is formed. So the particles are actually an agglomeration of around maybe 100-200 particles which are forming a single particle of dispersed phase. Okay? Is that okay? And therefore they are called multimolecular colloids. Their dispersed phase is not a single particle, rather it is a agglomeration of particles creating one single particle, agglomeration of smaller particles creating one single particle, which is a dispersed phase or which is creating the dispersed phase. ठीक है? मतलब dispersed phase के particle जो है वो unimolecular नहीं है, सिंपल सी बात है. ठीक है? Dispersed phase particles are not unimolecular, they are multimolecular. Many molecules have come together to form one such dispersed phase particle. Is that okay?
Yes, sir.
Yes, sir.
That's the key idea of multimolecular colloid. इसमें मैं definitions ना perfectly copy कर लेता हूँ, छोटे छोटे ही हैं. There is on dissolution, a large number of atoms or smaller molecules of a substance aggregate together to form species having size in colloidal range. The species thus formed are called multimolecular colloids. For example, a gold salt may contain particles of various sizes having many atoms. Sulfur salt consists of particles containing 1,000 or more of acid sulfur molecules. ठीक है? The second type is macromolecular colloids and then associated colloids called micelles. So, molecular colloids. सी मैक्रोमोलिकुलर कोलाइड का कैसा होता है कि यहाँ पर एक सिंगल मॉलिक्यूल ही इतने बड़े साइज का होता है दैट इज एग्लोमरेशन ऑफ मल्टीपल मॉलिक्यूल्स सच एज पॉलीमर्स कोई भी एक पॉलीमर मॉलिक्यूल अगर हम लेते हैं तो इट इज गोइंग टू बी ऑफ पॉली जैसे पॉलीथीन है तो इथीन जो है इथाइन या इथीन जो है दैट इज ऑफ वेरी स्मॉल साइज ठीक है बट पॉलीथीन का एक सिंगल मॉलिक्यूल जो होगा दैट इज गोइंग टू हैव अ लार्ज साइज isn't it? It won't be a small sized molecule. Similarly, हमारे पास कई एक सारे प्रोटीन्स है मतलब कई एक सारे बॉडी प्रोटीन्स है which is which is which is an uh, like which has size in the range of like they are actually polymers of very small amino acids or yeah amino acids and then they form polymers of those amino acids joined together and that yeah, polymer uh, behaves as a single particle or single particle of dispersed phase or it constitute one of the particle of the dispersed phase ठीक है और ऐसे कई एक सारे पार्टिकल रहेंगे that makes them macromolecular colloids ठीक है so basically molecule यहाँ पर जो होता है ना they are of polymeric type uh, and that polymeric nature of theirs make their size bigger enough to behave as colloids ठीक है मैक्रोमोलिकुलर कोलाइड्स में तो dispersed phase the dispersed phase is dispersed phase consists of large polymeric molecules which themselves formed by bonding. Small examples are starch, cellulose, proteins, enzymes. Uh, Wait a minute.